today I'm going to talk a little bit about functions where they increase and decrease by local and max and mins using the first derivative rule. All right. So I'm going to do some parts problems here from Stewart 5 edition. And I'm going to start with this function. H of x equals 3x to the fifth minus 5x cubed plus 3. I'm going to find the intervals of increase and decrease. I'm going to find the local max and min values using the first derivative rule. Again, first derivative rule says that if f prime of x goes from positive to negative, going positive to negative, then we have a local max. And the inverse of that if it is going negative to positive, there's going to be a local min. All right, so if I'm going to do this, I need the derivative, and I need to find the critical points. Big part of this, and just finding those. So on a polynomial like this, the derivative is rather easy. Look how pretty that works. If we look at this, and we should immediately see that 15x squared factors out. All right, and we should know this factors. You wouldn't have to write this, but I'll write it so that you can see it. Difference of two squares. So I sit here, I have next to the fourth there should be 4 zeros, and there are zeros repeated, so there's critical points at 0 and plus or minus 1. I would have taken those right from this step. Now if I was going to go on to find concavity parts C and D and inflection points, I would take the derivative of this. But today I'm just worried about critical points, which is found, where it's increasing, decreasing, and where it's maxing or mins. So there's our three critical points. So I'm going to make a table here of this situation. I have x, and I have f prime of x, and f of x. I really don't need the f of x column for this assignment, but I'll just put it in here. Three values. We know that they are all critical points, and they were all 0. It's a continuous function. There are no undefined portions. I would usually have another column here with f prime, but we'll go right to notes since we're only using the first derivative today. And I'll start by finding signs of the situation. And again, when I look at large positives and large negatives, since the derivative is an even function, I know it's positive here and here. Likewise, I know it'll be the same on both sides. So when I try a small fraction in between 0 and 1, I find that it's negative and negative. All right. We have now found the increasing and decreasing sections. It is increasing from negative infinity to negative 1 and from 1 to positive infinity. That's the answer to letter A. So negative infinity, negative 1, and 1 to infinity. It is decreasing where the first derivative is negative, which is simply negative 1 to 0 and 0 to positive 1. It is not increasing or decreasing at 0 because the derivative here is 0. Now we'll use the first derivative rule, and we'll look for change in signs across values here. And the first change in sign I find is going from positive to negative at the very top here of my chart in red. So I look here and I see it goes positive and negative. Again, and I always kind of think to myself a picture, positive and negative. That's a local max by the first derivative rule. If I want to know the value at negative 1, I can plug it back into my original function here, h of negative 1. Negative 3 plus 5. Negative 3 plus 5 is 2. 2 plus 3. So I think there's a value of 5 here. So there's a local max of 5 at negative 1. There is no max or min here at 0. There is no sign change. It goes negative to negative. So we simply leave that and move on. Then down here it goes from negative to positive. Again, it's a local min by the first derivative rule. And the first derivative changes sign across the point. And again, if I want to find the value, I can plug that in. Get 3 minus 5 is negative 2. Negative 2 plus 3, I get a value of 1. So there's a local min with a value of 1 at 1. So we have found the three critical points, negative 1, 0, and 1. We found a local max at negative 1 with a value of 5. We found a local min with a value of 1 at 1. And we can check this on our calculator. Pause the video, did a little graph in here, and the picture came up right here, and you can see at negative 1, there is a maximum here, and it is 5. And over here at positive 1, there is a minimum, and it is 1. You also notice at 0, there is no max or min, but there it does stop from decreasing. So again, you can see it's increasing to -1 and increasing from 1 on, and it's decreasing except at 0 and in between -1 and 1. And the three critical points are -1, 1, and 0. And those happen, and there are no undefined points, which would also be a third point. Again, keep practicing, all right, taking critical points and derivatives.